Hello. Okay, we're live. And red light's on, the numbers are blinking. All right. I'm Verdi Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube and Facebook. Thank you for being here. If you're new, welcome. Remember to like, share, comment, and subscribe. The more you interact with the channel, the more the algorithm pushes my videos up, further percolates them up in the system. I'm not monetized. I don't have any commercials. I just want you to get the information. I'm not getting any money on this. Just so you know. For the record, I was invited to be monetized. I had reached that platform. I did not send them back a reply on that. Just for the record, this is all public service, in my humble opinion. All right, so um, this is the 30th. As you can see, the title and the date on this is that I've been working with the same material for a few days now, and as I mentioned before, this is the deep dive analysis into the Schumann resonance and associated electromagnetic, atmospheric electromagnetics. In the same sense, I've explained this before, in the same sense you'd bring your bicycle into the shop, you'd leave it in there for a few days, we would work on it. It's the same basic principle here, that we have, a chunk of 48, hours, 72 hours, whatever it is, where we look at a continuous event and analyze it from, the coming and going perspective, a whole kind of the whole range of what any given phenomena is doing. And now here that we're in the middle of we're ramping up into a solar maximum. We have a lot of solar activity that's creating interaction with the Schumann resonance, the ionosphere, and a lot of these other associated electromagnetics of the local variety. All right, so I'm trying to keep the introduction to this as little as possible. You can read the background to this, basically the introduction, and I may be kind of tweaking it a little bit more as I put in the description in YouTube. Kind of expect that on all of this stuff, pretty much. And so what I've been doing is kind of this last 6 months. I'm at the 1 year period of the Schumann resonances on YouTube, having posted Schumann resonance videos. This channel dedicated just to Schumann resonances. I've been doing other stuff, before that wasn't specifically Schumann. The last year dedicated only to Schumann resonance and related, like I said, related atmospheric electromagnetics. All right, so this is one of those vocabulary lexicon, a shared vocabulary, a common vocabulary, words that we all know and all understand. Our group will just say the Wages World family. For example, those of you who follow, not just Wages, a lot of you, most of you are from Wages, and you follow him, but also Suspicious Observers and the Real BP Earthwatch, big on a lot of these, the terminology and the specifics and the technical details. And that's what I'm here to do as well. This is a scientific, technical exploration of these phenomena, associated phenomena. So we have up here the keywords. All right, keywords. Hello, keywords. All right, there we go. All right. So this is, whenever you see keywords here in my stuff, just know that this is a lexicon lesson. A lexicon is a subset of a vocabulary. The vocabulary is the word set that we all use, but a specific subset of vocabulary that a specific group uses is called a lexicon. A shared vocabulary that everyone in the group pulls from to build our communication, our communal flow, ebb and flow of ideas, depends on the lexicon, the particular roadmap, the the roads of the words we use to express our ideas. Okay, so I'm at the 5:30 mark. Let me pause this, take a break. I need to clear my throat and have a drink. So, all right, 5-minute pause. All right. So, what basically I was saying, to kind of summarize, is that in the last 6 years, I've been paying more attention to doing posts that deal with building and defining the words, the vocabulary, our our lexicon, our shared words that we use. So it's important that we got to get. I always maintain that one of the technical principles of doing not just any technical project, but the human resonances, is get back to basics. When things get overwhelming, when you are overwhelmed, go back to the basics. Sometimes the basics, the most basic thing may be check your breathing, watch your breathing. There's other, in posts I've made mention of other basics relative to, the topic, but always the principle is go back to the basics. What's the most basic thing that we know? What is the most basic thing that I know? All right, so before moving on with our vocabulary, before moving on to the lesson, we need to build and define our vocabulary. And the common vocabulary, the lexicon we use, is like, for example, these right here, the key words that I want to discuss in this and the next part 2 of this that goes with it. The solar bursts and solar flares. All right. So before I was originally going to do the video on the difference between solar bursts and solar flares, and then it was like, wait a second, there's some terms in there that should be identified first. So then I said, all right, well, let me do this one, and then we could move on. Move on to the next one. Just as a precursor, a peek, a teaser, I guess. The information on solar flares there's a lot, because it goes into the classes, how they measure the C class or X or M class or any of that. So that that's why I broke this into two lessons, because the other one's voluminous. Okay, so that said, let me get into the material, and I'm just going to read this without any of the visuals. There's going to be a live stream that accompanies this that'll have visuals, and as I've been doing these, there's another part to it. So this is just like the text that you all can listen to in your spare time. So without further ado, I'm going to read. There's 3 parts. What is the solar cycle? What is the sunspot? And then what is the solar wind? And then these are the links, and then we're done. So this should be relatively painless. So, all right. So the 9-minute mark. It's just under my traditional 10-minute introduction. So I'm going to clear my throat. Let's pause this for a minute. Okay, let's see how well I do. All right. Just really quick, just a general disclaimer. Obviously these can have very long answers depending on where you look. So I did a quick search, because there's a bunch of them. So some of the answers are longer depending on where they go. So I just want to say that I want to give a basic introduction. And I skipped over some answers that were, some websites just had a really short answer, and I'm like, no, I need a little more information than that. All right. So this is just to kind of peruse, around the available sources, what's available. All right, so the solar cycle. What is the solar cycle? Our sun is a huge ball of electrically charged hot gas. This charged gas moves, generating a powerful magnetic field. The sun's magnetic field goes through a cycle called the solar cycle. All right, and I think I should be maybe highlighting these. Every 11 years or so, the sun's magnetic field completely flips. This means that the sun's north and south poles switch places. Then it takes another 11 years for the sun's north and south poles to flip back again. The solar cycle affects activity on the surface of the sun, such as sunspots, which are caused by the sun's magnetic fields. As the magnetic fields change, so does the amount of activity on the sun's surface. Okay, and this is sunplate. The source, the link to it is below. All right, so basically, a solar cycle is an 11-year cycle of recorded sunspot activity. All right, there's more to it. This will suffice. And just as a side note, that 11-year cycle relates to Jupiter's orbit. Just as a FYI. Okay, sunspot. What is a sunspot? Sunspots are darker, cooler areas on the surface of the sun in a region called the photosphere. The photosphere has a temperature of 5,800 degrees Kelvin. Sunspots have temperatures of about 3,800 degrees Kelvin. They look dark only in comparison with the brighter and hotter regions of the photosphere around them. Sunspots can be very large, up to 50,000 kilometers in diameter. They are caused by interactions with the sun's magnetic field, which are not fully understood. But a sunspot is somewhat like the cap of a soda bottle. Shake it up and you can generate a big eruption. Sunspots occur over regions of intense magnetic activity, and when that energy is released, solar flares and big storms called coronal mass ejections erupt from sunspots. Okay, the link is below. That's by space.com staff. Okay, more on sunspots. Sunspot vortex of gas on the that's a picture there. That's what that text is. There's a picture you're not seeing. So all right. Sunspots look dark only by contrast with the surrounding photosphere, which is several thousand degrees hotter. The dark center of a spot is called the umbra. The outer lighter ring is the penumbra. Spots may be several times larger than Earth, or so small that telescopic observation is difficult. They may last for months. Single spots do appear, but most are in pairs or groups, with the members of a pair, leader and follower, in respect to the direction of the sun's rotation, having opposite magnetic polarity. This polarity reverses from one solar cycle of 11 years duration to the next, i.e., if leaders in one cycle are north magnetic poles, leaders in the succeeding cycle will be south poles. Leaders and followers are one hemisphere of the sun are almost always opposite in polarity from their counterparts across the equator. By observing spots, English astronomer Richard C. Carrington found, in circa 1860, that the sun rotates not as a solid body, but differentially, fastest at the equator and slowest at the high solar latitudes. Okay. Sunspots are never seen exactly at the equator or near the poles. George Ellery Hale in 1908 discovered their magnetic fields, which are about 2,000 to 4,000 Gauss in strength. Earth's oh my God, that's such a difficult word. Earth's, without sounding like you're hissing it out. Earth's magnetic field has a strength of 1 Gauss. Okay. John Evershed in 1909 detected the radial motion of gas away from sunspot centers. Annie Russell Maunder in 1922 charted the latitude drift of spots during each solar cycle. Her chart is sometimes called the butterfly diagram because of the wing-like shapes assumed by the graph. Each solar cycle begins with small spots appearing in middle latitudes of the sun. Succeeding spots appear progressively closer to the sun's equator as the cycle reaches its maximum level of activity and declines. Okay, and the Richard Pally, this was Britannica. I want to just as a kind of a side note here, some of you may recognize the names Maunder. There's the Maunder minimum. Okay, that's her right there. And the Hale. Hale is the name of an observatory. And this is not the Hale of Hale Bopp, I'm pretty sure. And Carrington, who bears the name of the Carrington event. And 1860 would be the year immediately following the so-called Carrington event, for those of you who are keeping track of such things. Okay, all right. Onward and upward. Solar wind. What is the solar wind? All right, you hear a lot about that, the solar wind. Okay. And where are we? All right. Not too bad. The solar wind is a flow of particles that comes off the sun at about 1 million miles per hour and travels throughout the entire solar system. First proposed in the 1950s by University of Chicago physicist Eugene Parker, who also has a probe named after him. The solar wind is visible in the halo around the sun during an eclipse, and sometimes when the particles hit the Earth's atmosphere as the aurora borealis or northern lights. When the solar wind protects Earth from other harmful particles coming from space, storms can also threaten our satellite and communication networks. The surface of the sun is blisteringly hot at 6,000 degrees Fahrenheit, but its atmosphere, called the corona, is more than 1,000 times hotter. It is also incredibly active. Those flares and loops are the halo you see around the sun when there's an eclipse. The corona is so hot that the sun's gravity can't hold it, so particles are flung off into space and travel throughout the solar system in every direction. As the sun spins, burns, and burps, it creates complex swirls and eddies of particles. These particles, mostly protons and electrons, are traveling about 1 million miles per hour as they pass Earth. This flow of particles, called the solar wind, has an enormous impact on our lives. It protects us from stray cosmic rays coming from elsewhere in the galaxy, but the effects of storms on the sun's surface can also affect our telecommunications network. Okay? The wind would also pose a threat to astronauts traveling through space, so NASA wants to get a better understanding of its properties. The science behind what is happening on the The science behind what is happening. This was a link. On the sun's surface is enormously complex. Read more about it at this link here. All right. So okay. All right, and so the links are there. And this is the Schumann resonance, Schumann-resonance, the website, my website link, and that is it's public, it's shareable. I want to get the information out to as many people as possible. Okay, that ends this video. There's going to be like I said, there's going to be a live stream with the visuals and whatever we're going to do with this. But this, I just want to get this information out. All right, so it's now actually Sunday morning where I'm at. It's 12:28 a.m. All right, so thank you all for being here. Those of you who watch, I appreciate it. The comments, thumbs up, definitely the likes, the comments. I appreciate everyone giving me their opinion on this, and we will talk to you soon. I did this mostly for Wages World, like for the live stream, the chats, so I can send a link to people so that they have, and for my audience as well, for those of you here, so you know what the doohickeys are, the cosmic rays and all this kind of stuff. What the heck we were just talking about? The solar wind, yeah, not the cosmic rays, whatever. It's in there. That's another one that I was going to do. If I didn't already do this, I would include what the cosmic rays are. That's different from the solar wind. Anyway, I'm running on. All right, so thank you all for being here. Have a good rest of your night. Namaste.